Hello there. So this is going to be a video about substitution. This will be part one. So the whole idea behind substitution is you're going to replace something with something of equal value. For example, in basketball, if you're taking a center out of the game, you're going to substitute in another center. You want to make sure they can do the same job because they're equal, so to speak. So here, for example, if I say that $1 equals 4 quarters, I could also say $1 equals 10 dimes, same thing. You wouldn't care if you had 10 dimes or 4 quarters or $1 bill. They're all worth the same amount. So it would be fair to say that since $1 equals 4 quarters and $1 also equals 10 dimes, that 4 quarters and 10 dimes must also be the same as each other. So they must be equal since they both equaled $1. So basically, what happened here is that since $1 equaled 4 quarters, I substituted 4 quarters in for the dollar in this second equation. These two things are equal, so 4 quarters can stand in for $1. So this is the second equation when I made a substitution for the dollar. So here's how it works with a regular equation. The first thing you have to have is a variable that equals something. So this one, somebody's already done the start. And this is what part one's about. Somebody already found out what one of the variables equals. Since y equals negative 7x plus 11, I can use negative 7x plus 11 instead of y because it means the same thing as y because they're equal. Why would I want to do that? Well, if you have an equation with two different variables in it, an x and a y, you can't solve it. But if you have just x's or just y's, you can. So watch what happens when I make this substitution. Since this green stuff equals y, it's the same thing as y, so I can substitute it in for y right there. So if I take this second equation, make a substitution for y, I'm going to use the negative 7x plus 11, then I'll have an equation here. Here's the substitution I made. Put that in instead of y. Now I have an equation that has only x's in it. This I can solve, and you've been doing this since first week of school. So you'll use all the steps you've always used to solve. So negative 2x, this will give you negative 14x, and that'll give you positive 22 equals 6. Then you need to combine like terms. So negative 2 minus 14 is going to give you negative 16x plus 22 equals 6. And then you'll minus 22 from both sides. And then negative 16x is going to equal negative 16 when you do 6 minus 22. So then when you divide, you're going to get x equals 1. So in the past, you've been solving a system of equations by graphing them. You'd solve them both for y, put them on the graph, and see where they cross. Substitution is a mathematical way to do that in case it's not feasible to graph them. So we just found out that this system has a solution. When x is 1, we need to find the y coordinates so that we can figure out the point where these two lines cross. Well, if I plug that 1 back in right here, it's x. So I plug it right back in here for x. I make a second substitution. So I'll use that first equation, y equals negative 7 times x, which we know is 1, plus 11. So y equals negative 7 plus 11, and that would be 4. So the solution is 1, 4. X was 1 and y was 4. So that's how it works. You find one of the variables, you have to solve for one variable so you know what equals it, and then you can substitute it in for the letter that it equals. We'll do more. Here's a second example. Sometimes the simple ones like this confuse kids. Right here, they say y equals 4. So 4 is the same thing as y. So I'm going to put a 4 in right here. And I already know what y is because they told me it equals 4. So that's a strange start, but that could happen. So since this is equal to y, I'm going to replace y with it. So I'm going to look like negative 3x plus 6 times 4 equals 6. Negative 3x plus 24 is what I get when I multiply that. And then I'll minus 24 from both sides. And I'll get negative 3x equals negative 18. And when I divide, I will get x equals 6. So the point 6, 4, x was 6, y was 4. Remember, they told us that at the beginning, so I don't need to plug this back in. That is the point where these two lines would cross. It's also the point where if I plugged 6 in for x and 4 in for y, this equation would be true. Same thing with this one. If I plug 4 in for y, 4 equals 4. True. We'll do one more. So here's an example a little bit more like the first one. First, we have to find a variable that equals something. Here's one. Y equals this stuff. So put a box around this stuff. All of this stuff right here is the same thing as y. So I can put it in right here instead of y. I'll put in negative 5x minus 14. Since it's equal to y, I can make a substitution. And I would want to do that so that I could create an equation that only has one kind of variable in it. And then my equation would look like 6x plus 7 times negative 5x minus 14 equals 18. There's the substitution I made right there. It used to be y, but now it's the stuff that's equal to y. So when I simplify this, I'd get 6x, that would be negative 35x, minus negative 98 equals 18. When I combine like terms here, 6x and negative 35x, so 6x minus 35x would give me negative 29x, and then bring down this negative 98 equals 18. When I add 98 to both sides, I'm going to get 116. So negative 29x equals 116. And when I divide by negative 29, I'm going to get x equals negative 4. So there's part of my solution. X is negative 4, so I'm making sure I put it in the x position. Now I have to put it back in to find out what y is. So put it back in there because I know that y equals negative 5. And I'm going to put in my negative 4 that I found out for x minus 14. So you can always go back to what you boxed up at the beginning to plug in your first value. So y equals 20 minus 14. So that means y is going to be 6. So the solution would be negative 4, 6. If I solve those both for y and graphed them, here is the place where they would cross. I think you're ready to give a try to substitution part 1. Good luck.